important problem. So that is, find the Laplace transform of sin 2t and cos 3t. So this is the product of the two functions. So now we don't have the formula to find out directly the Laplace transform of product of two functions unless it is put as the difference of the two elementary functions or the sum of the two elementary functions, so that the problem can be solved. But one logic is there in transformation chapter trigonometry. We have this cos A sin B, that means 2 cos A sin B can be written as the sin of A plus B minus sin of A minus B. With the help of the transformation, the formulae, we can express this sin 2t and cos 3t as the difference of two trigonometric functions, that is sin of at or cos of at in terms of, so that the basic formulae can be applied. So this kind of strategy has to be followed to solve this problem, or this method has to be adopted. So let us solve this problem now. So because it's very important for even engineering M1 examination as well as diploma examination for engineering mathematics, diploma mathematics M4. So let us solve this problem now. We need to recall the formula. We know that two cos A, because if you say 3t is greater than 2t, let us consider cos A, and sin B equals to sin of A plus B minus sin of A minus B. You can derive yourself also, you can check. If you subtract sin of A minus B from sin of A plus B, you get 2 cos A sin B itself only. Now the cos A sin B can be written as 1 by 2 times the sin of A plus B minus sin of A minus B. Just if you recall this formula, this problem becomes very simple. It's not a complex problem. It's very easy. So now A for 2t, B for 3t. So now we need to write sin 2t cos 3t is equal to half times sin of A plus B, 2t plus 3t, directly we can write 5t, minus sin of, here A is 3t, don't get confused, 3t minus 2t, or this we can write cos 3t sin 2t also, no problem. So now in order to find out the L of sin 2t and cos 3t, it is enough to find out the Laplace transform of half times sin phi t minus sin t using only one of the basic formulae, that is Laplace transform of sin at, whose value is equal to a by s square plus a square. So let us solve it now. Now Laplace transform of sin 2t cos 3t equal to or equals to Laplace transform of half times sin phi t minus sin t. Okay. Using the linearity property, this half shall be taken common out, half into L of sin phi t minus L of sin t. So now we need to recall the formula, that is L of sin at, whose value equal to a by s square plus a square. Okay. So now half times the sine phi t is, we can write a for phi by s square plus phi square minus here a for 1, because here at is compared to t, a value becomes 1, and 1 divided by s square plus 1 square. Let us distribute after the first term as well as the second term. So this can be written half into phi divided by 2 times s square plus 25 and minus 1 divided by 2 times s square plus 1. So this is the answer. You can check it. So let me read the question first. Find the Laplace transform of cos 4t sin 2t. So it is just like the previous problem itself only. So I need not explain, directly I shall move to the problem itself only. So because we need to write as the difference of the two trigonometric functions, after that we can apply the Laplace transform elementary formulae. So let us solve this problem now. We know that we know that 2 cos A sin B, whose value equals to sin of A plus B minus sin of A minus B. Okay. So now this cos A sin B equals to 1 by 2 times sin of A plus B minus sin of A minus B. Don't get any confusion here. A is being replaced by 4t, B is being replaced by 2t. So now therefore cos 4t sin 2t can be written as half times. So directly we can write A plus B, 4t plus 2t, 60, that is sin of 60, minus sin of difference of these two angles, 4t minus 2t, that is 2t. So now it has been expressed as the difference of the two sine functions, so that we can apply the Laplace transform. Now Laplace transform of cos 4t sin 2t. Okay. Now instead of the cos 4t and sin 2t, you can write the Laplace transform of, you can write like this, half times sin 60 minus sin 2t. Okay. Now it is the time to apply the linearity property. Half is taken common out. Half times the Laplace transform of sin 60 minus Laplace transform of sin 2t. The one simple formula has to be recalled here. So that is nothing but Laplace transform of sin of at. Am I correct? Do you know what is the value of the Laplace transform of sin of at? Yes, why not? You might have practiced so many times. So that is nothing but a by s square plus a square. So let me recall the formula. Laplace transform of sine at, the whose value equal to a divided by s square plus a square. So this is the formula. So with the help of this formula, these two values can be written as half times here 6 divided by s square plus 6 square and minus 2 divided by s square plus 2 square. Just only one step we need to write. Let us distribute half. So half times 6 divided by s square plus 36 minus half times 2 divided by s square plus 4. Simplification takes place now. So now we can write 2 1 ja 2 3 ja 3 divided by s square plus 36 and minus 2 gets cancelled. We have 1 divided by s square plus 4. Am I correct?